Real gases are not ideal. They all interact and they all have volume. But we can make the assumption that a gas will behave almost ideally when temperature is high and pressure is low. At a high temperature, gases are going to be moving more quickly. And that means that the relatively weak dispersion forces aren't actually strong enough to pull the particles together. So high temperature will mean that the attractive forces are very much minimized. At low pressure, gases are so dispersed and at such low density that they just simply aren't as likely to get close enough to one another in order to interact. But sometimes you encounter gases that are not at a high temperature or not at a low pressure, and they don't exhibit ideal gas behavior. They behave like real gases that have messy, difficult behavior. But there is a modified version of the ideal gas law that accounts for real gas behavior. The van der Waals equation looks very similar to the ideal gas law, but with a couple of small additions. The two added terms are going to account for interactions between gas particles and for the gas particles having real volumes. And the values for A and B are experimentally determined constants that you simply look up for each individual gas you're working with. So you can find an A and a B value for methane, and a different A and a B value for carbon dioxide, for example. And once you have the A and B values for a gas, using the equation is about as straightforward as using the ideal gas equation.